Good evening everybody. I am Jayshree from SNS College of Technology. I am going to take the topic about full adders. So before full adders, what they used. Okay, let us recall what are the topics or what are the measurements used before the full adder. Okay, so biomedical devices, they use ECG analyzer or heart monitors worked with single input signals at a time. That is what just A and B. They could not be combined multiple biosignals or process previous patient data states. So that is the purpose we are going for full adders. So let us see the empathy stage of the full adder. What is the understanding? That is understanding the need for the full adder. So manual binary addition with carries time is time consuming and error prone. It need to handle carry from previous stage in multi-bit addition. Existing half adder is insufficient for cascading multi-bit operations. Requirement of faster and compact logic for ASIC and FPGA implementations. So here we see this diagram, full adder consisting of three inputs. Okay, so antigen, serum with antibody and complement. So finally we get this complement fixation. So this is what this full adder is applicable to the biomedical students. Let us see the defined stage. The full adder solves the problem by taking the three inputs and producing two outputs. The three inputs namely A, B, C in. And the producing output is what? Sum and carry. So sum is equal to A plus B plus C, whereas carry is equal to AB plus BC in plus AC in. So biomedical mapping, it should be requirement combine multiple psychological signals with memory of past state. Okay, so when it is going to the biomedical stage, so generally this full adder is what? Three inputs and two outputs. Okay, when it comes to the biomedical stage, it consisting of combining psychological signals with memory of past state. In the pacemaker, decisions are made by combining current heart rate, threshold comparison and previous beat history. So that is what output is equal to stimulus signal sum plus alert or backup control. Next it is what? IDA stage. So use full adder blocks in series to build multi-bit adders, ripple carry adders and carry look adders. It consisting of many number of full adders. So multi-bit full adders, we can add the many number of full adders bit by bit. Okay, and idea it is what? Wearable health monitors, and idea 3 is what? Signal fusion in ICU monitors, where heart rate and SpO2 and respiration dates are integrated, that is data are integrated for alarms. Next one is what? Prototype. So we already know that full adder consisting of three inputs, right? So similarly, two half adder form the full adder. So the two half adder contains two inputs and two outputs, whereas in full adder contains three inputs and two outputs. So this is what this prototype circuit for this full adder. Inputs A and B are biomedical signal bits. C in carry representing previous sensor reading and output represents the sum and C out. It uses the LEDs or digital display models for observing output. At last, the fifth stage is what? Test stage. We need to test the circuit, right? Let's verify the circuit output for all 8 input combinations 2 power 3, ensuring correct logical behavior. It measuring the voltage levels at logic 1 and logic 0 to ensure compatibility with ADC and DAC interface used in biomedical circuits. So tester performance under varying supply voltage to reflect medical deviceability and requirements. Okay. This is what this mind map for the full adder. The full adder concept, IDA stage, digital concept and biomedical mapping, and use full adder blocks in series and types of multi-bit adders. So let us see the assessment for the full adder. So how is the concept of multi-bit full adder is applied in CT or MRI systems? So there are 4 options here. Hint: think about how the final and coherent image is created from thousands of individual data points captured by the scanner. Okay, in the CT scanner and MRI scanner, we have the thousands of data points are captured by the scanner, right? So need to coherent with particular inputs and it produce the particular outputs. When the patient of the value is a most abnormal condition, that comes as the output. So okay, so you should find out the answer, and thank you all. Have a great day.